In the next class, we're going to be looking at mathematical modeling, also known as word problems. It's something that a lot of kids just leave open because it tends to be the question that distinguishes the 80s and the 90s students from each other. However, if you understand how simple it actually is, then it's not something that you should be skipping in a test. So we're going to be looking at two different questions today. So shopping problems and speed, distance and time problems. So with your shopping problems, you always have to remember that your total cost is equal to your price per item times the number of items that you bought. Right, so the example we're going to look at here is a grocery store orders a certain amount of avos at a cost of 600 Rand. When they are unpacked, it is found that 20 are bruised and cannot be sold. By selling the remaining avos for 4 Rand more than they were purchased for, a total profit of 200 Rand is made. How many avos were purchased and at what cost? So what we're going to be looking at is the fact that my profit is equal to my selling price minus my cost price. Alright, so what we have at the moment is we know the profit that was made. However, the selling price and the cost price are not known. So what I'm going to do is I'm going to go and draw up a table. Okay, these mathematical modelings work a lot better when we have tables so that we can actually visualize what is going on. Okay, so we're going to have the first one for bought, and then we're going to have the one for sold. So how much did the salesperson buy it for and how much did they sell it for? Then we're going to have our number of avos. We are going to have the total price, and then we're going to have our price per avo. Right? If we go back to our little table, that's exactly what we have here. We have our total cost, we have our price per item, and we have our number of items. So my number of avos that I have that I bought, I don't know. But what I do know is when I sold them, there were 20 of them that were bruised and I couldn't sell them. So the amount of avos that I actually sold was X minus 20. The total price over here that I bought them for was 600 Rand, or not me personally, but the salesperson. And the total amount that it was sold for was 800 Rand. And I know that because of this over here. They tell me the profit is 200 Rand. Now to get the price per avo, I'm going to say here 600, it's the total amount, divided by X. Then for the sold one, I'm going to say it is going to be 800 over X minus 20. All right. Now I can go back to this part over here and I can go and say my profit is going to be equal to the selling price minus the cost price. So now I can go and fill those things in. So my profit was 4 Rand, because remember now we're working with the individual avos. So it was 4 Rand is equal to my selling price minus my cost price. From this point, I can go and get an LCD, which is obviously going to be the following. And if it helps you, put that over 1 so that you could conceptualize that. So now I'm just going to go and multiply everything with my LCD. And because it's an equation, my LCD is just going to fall away. Right, now I'm over here. If I go and multiply all of this out, I'm going to end up with the following. At this point, I can go and factorize it. So X was obviously 100 avos. I can't buy negative 30 avos unless somebody steals my money. Alright, so basically what I bought was 100 avos, and now to determine the price, so now I've got an X. To go and get my price per avo, I'm going to go back to this part over here, and I'm going to say 600 over 100. So I paid 6 Rand for each avo. Alright, now the next question we're going to be looking at is the speed, distance, and time question. So always remember your distance is equal to your speed multiplied by your time. So Jane is traveling at 360 kilometers from Johannesburg to Nelspruit, where she travels 30 kilometers per hour faster on her return home. By traveling faster, she saves 1 hour on the return journey. Determine the speed she travels at. Alright, so what we're going to be looking at is we're going to say time saved is equal to longer time, so her time there, minus her shorter time, so her return back. Then I'm going to go and draw myself my table. And inside my table, I'm going to go have my, oh my, this table's a bit big. So we have a there and a back. Then we're going to have our speed, our distance, and then our time. So how do I know what to put in the last column? Well, because I'm working with time saved, I know that time is going to be the factor on which I'm going to be modeling everything. So that's why I basically want to get time. So the speed that I traveled at my original to my original journey, or Jane, was X. I have no idea what it was, but I know coming back it was 30 kilometers faster. Right? My distance for both of them won't change. It's going to be 360. Now, if I go have a look over here at time, my time is distance divided by my speed. So now I can go and say 360 divided by X, and this one is 360 divided by X plus 30. Now, the time that I saved was 1 hour, and my longer time was 360 over X minus 360 over X plus 30. I have to now go and get an LCD. My LCD being X plus 30. Right, now I'm just going to go and multiply everything with my LCD. And then I can go and solve from there. Okay, so my answer is either X is 90 or negative 120. It can't be negative 120. So my speed was 90 kilometers per hour. So they asked us over here, determine the speed at which she returns. So remember, it was 30 kilometers faster, so it was 90 plus 30 gives me 120 kilometers per hour.